In this video, we are going to take a look at correlation, and specifically we're going to look at linear correlation. So a correlation between two variables, this occurs if one variable is somehow related to the other. Right? So we say that there's a correlation if they are related. We can talk about how that correlation looks specifically. So if that relationship is a line, then we say that there is a linear correlation. Right? So if that scatter plot, if it looks approximately like a straight line, there's a linear correlation. We can describe types of linear correlation. So here, when we look at this first scatter plot right here, when we take a look at that scatter plot, we observe that those points, they're not perfectly on a line, but they're approximately on a line. So this has a strong positive linear correlation. Right? So these points, they lie approximately on a straight line. That straight line not only is approximate to all those points, it also is a straight line with a positive slope. This next graph to its right, those also approximately lie on a straight line, but that straight line has a negative slope, so we would say that that is a strong negative linear correlation. For the next graph on the bottom left, there's not really a great line that's going to approximate that, so you might draw a line here. That line isn't a very good line. We would say that there is no correlation. And then this fourth and final graph, when we look at it, we might see there might be a line that's kind of okay, but there's a better line than a straight line. This looks kind of exponential in growth. And so there's some sort of correlation that's happening there. It's just that correlation doesn't happen to be a line. So this is part of why we will look at scatter plots when we're trying to identify correlations. And yeah, so this has a non-linear correlation. So when we think about these linear correlations, we can try to measure the strength of that linear correlation. And we use something called a linear correlation coefficient. This is an R value. It measures the strength of a linear correlation between two paired values, x and y values. With that correlation, we can do a hypothesis test for this. And so for this hypothesis test, we can say that rho, that is the population's correlation coefficient. That's the Greek letter rho. It looks like a P. That if that rho is close to 0, then there is no correlation. And if it's not 0, then there is evidence of a linear correlation. Now, having that evidence, we also want to look to see maybe there's a better nonlinear relationship. And so we can look at the scatter plot to determine if there is a nonlinear correlation that's showing up. So if I look back up here, for these R values, for this linear correlation coefficient, those R values, they will always be between -1 and +1. If the R value is closer to 1, then it is going to be a strong positive linear correlation. And so when we look back up here at these scatter plots, this first scatter plot, it would have an R value that is pretty close to +1 because it's a strong positive linear correlation. The second graph, it would have an R value that's pretty close to -1 because it is a strong correlation. That correlation, the negative sign is going to indicate is it a strong positive or negative. The closer it is to either +1 or -1 indicates a stronger linear correlation. That third graph down here in this bottom left, this would have an R value that is pretty close to 0. And finally, this graph here that's in the orange, that's probably still going to have a decently large R value. And when I say large, an R value that is maybe kind of close to 1. You could imagine a straight line here drawn like this. That fits the data kind of decently okay. So you might get an R value there that is maybe around 0.7, which is pretty strong. However, when we look at the scatter plot, we can say even though that R value is really strong, the scatter plot suggests that maybe it's not a straight line relationship. Maybe there's a nonlinear relationship that's happening instead. So that's how we deal with these R values with correlation. It's how we might go through and test for correlation. And in StatDisk, we can do that using this. So here are some steps in StatDisk. You copy and paste your data into columns 1 and 2. We're going to choose analysis, correlation, and regression. This will do the hypothesis test if we want it. It will also do a calculation for that correlation coefficient. We will need to input a significance level. So if we're only looking for that correlation coefficient, then we can plug in any value there. But if we're trying to do this hypothesis test to see if there's a linear correlation, we would need to have that other value. The independent variable, that is our predictor variable, the thing that you would use to try to predict the other value. We will put that in first, and then the dependent variable, the value that you would try to hypothesize or make a guess about based on an input variable, we call it a response variable. That y value, we should input that in second. Then we press evaluate. This will output all kinds of stuff that we might be interested in. The regression coefficients we'll talk about in our next video. And if we want to see the scatter plot, there's a spot where we can click on that and see the scatter plot. All right, so let's look at an example. The suggested opening bid and actual winning bid of various auction items are shown in the table below. We want to construct a scatter plot, find the value of the linear correlation coefficient, and find the test statistic and the p-value of this correlation coefficient. So for this correlation. So determine whether there is sufficient evidence to support the claim of a linear correlation between opening bid and winning bid. Should we expect a correlation? Use alpha equals 0.01. All right, so here alpha is 0.01. We're testing the claim of a linear correlation. So our null hypothesis is there is not a linear correlation. And then our alternative is there is a linear correlation. So when it's equal to 0, this is no linear correlation. That's our null hypothesis. The alternative is there is a linear correlation. So I'm going to go to StatDisk. I'm going to copy this stuff into StatDisk. So I have already done that. So over here in StatDisk, The first column is the suggested opening bid. The second column is the actual winning bid. And so I'm going to choose analysis. I'm going to choose correlation and regression. And we need to select the columns for the x and the y variables. So our x variable, that is going to be the input value, our predictor variable. So if we knew the opening bid, which is the first column, we might be able to guess the winning bid, right? We probably wouldn't go and say, I know the winning bid. What was the suggested opening bid? That doesn't seem like the route we would typically go. So we think about the second column there, the actual winning bid, as the response variable. It responds to the opening bid. And so then we evaluate that. And when we evaluate that, we get all kinds of information here. So we have our correlation coefficient is provided right there. So 0.932 is the correlation coefficient. That's the R value. We have our critical R value and a P value. Our P value is 0.02. We notice that 0.02 is greater than 0.01. When the p-value is high, the null will fly, so we fail to reject the null. So let's go back here. I should have actually changed the significance level to 0.01. I forgot to do that. It won't do anything other than changing the critical value, and so I'll change that critical value a little bit. The p-value won't change, so our p-value stayed the same, 0.021. Our correlation coefficient, it stayed the same. But that critical value changed. Our regression results are shown there. We don't need those here, but in the next video we'll take a look at those. So the only other thing we needed to look at in this is the scatter plot. So we can click on the scatter plot, and there's the scatter plot. And so in this scatter plot, we have our points. So we see 1 point there just under 300, a point just under 200, and a point just over 100. That point above 100, that's actually 2 points because we had two different values with a 500 suggested opening bid and a $125 winning bid. And then we have that one other value up there just above 600. So we have those 5 values that are there in our scatter plot. I'm not going to redraw this, but we could write this down as well. So that's how we would go through finding some of that correlation. In the next video, we will look at regression.